Welcome to the Deep Dive.
Great to be here.
Today we're diving into a stack of sources you've shared, all focused on something buzzing in the tech and business world. Agentic AI.
That's right. Specifically, its potential to unlock significant economies of scale.
We've got reports on cost breakdowns, architectural analyses, implementation guides. Quite a collection.
Yeah, it covers a lot of ground.
So our mission in this deep dive is to cut through that noise, pull out the most important nuggets for you. We want to understand exactly what agentic AI is in this context, what it, really costs, how it might generate those scale economies, the significant challenges standing in the way.
Definitely some challenges.
And what the sources say are the strategic paths to actually making this work.
Think of this as your shortcut, your guide to getting a solid handle on the economic picture of this cutting-edge tech.
The potential for big efficiency gains seems clear in the sources.
Oh, yeah, it's definitely highlighted, but they also make it really clear this isn't, a simple switch you just flip.
Right. Significant hurdles.
Yeah.
Careful navigation needed.
Exactly. It's a nuanced picture.
Okay, so let's start at the beginning then. What exactly are we talking about when we say agentic AI? It sounds like maybe a step beyond what most people think of as AI.
It absolutely is, yeah. The sources describe agentic AI not just as a passive tool you give a prompt to, but as proactive systems.
Proactive how?
Well, these are systems designed to autonomously take actions, make decisions to achieve a specific goal they've been given. They can plan out multi-step processes on their own,
Good.
learn from their experiences and interactions, and even collaborate, sometimes with other AI agents, sometimes with human users.
So they have a kind of independence, a purpose built in.
That's a good way to put it. A level of independence and purpose, yes.
And what about the architecture? What makes that kind of autonomy possible according to the sources?
Yeah, a few key architectural principles kept coming up. Modularity is one big one.
Breaking things down.
Exactly. Breaking complex functions into specialized, manageable parts. Scalability is another. They're designed or should be designed from the ground up to handle more data, more tasks.
Excellent.
Then there's interoperability, meaning they can work together, hopefully seamlessly. And a really important one. Reinforcement learning.
Learning from doing.
Right. Continuously improving by learning from the outcomes of their actions.
It sounds like some of those characteristics, like scalability and learning, are almost purpose-built for achieving economies of scale. Is that connection made explicit?
It really is. Take autonomy, for instance. The idea is, as your volume of tasks increases, you theoretically need less human oversight compared to traditional systems or, obviously, manual processes.
Okay.
And the learning capability. That's fascinating. It means performance can actually improve as the system handles more volume.
So costs go down per unit, but quality goes up.
Potentially, yeah. Which is a powerful synergy with scale economies. And things like modularity, interoperability, they enable technical efficiencies, like reusing agent components, which saves development costs as you expand.
Okay, so that connects directly to the classic economic idea of economies of scale.
Exactly. That fundamental concept where cost per unit goes down as you produce or deliver more.
Because you're spreading those fixed costs, the factory, the software R&D, over a larger output.
Precisely. We see internal economies within a company, technical, managerial, purchasing power, and external ones like industry-wide expertise or infrastructure.
And tech economies of scale are often, particularly strong, right? Software duplication costs almost nothing.
Near zero marginal cost of replication, it's huge. Plus, you have those very high upfront R&D costs you want to spread thin, and network effects sometimes where more users make the service better for everyone.
So the core question for this deep dive really becomes, can agentic AI, with its unique setup, its capabilities, its cost structure, can it truly tap into those powerful tech-driven economies of scale?
And to figure that out, we really have to dig into the costs involved because it's definitely not free to get these systems going.
Right. So what did the sources reveal about that economic landscape?
Yeah.
Where does the money actually go when implementing agentic AI?
Well, there are several pretty significant cost components you need to wrap your head around. Because like you said, economies of scale are all about spreading these costs over more activity.
Yeah.
Lay them out for us. The first big one is the initial development and R&D.
And how much are we talking? Is it all over the place?
It is, yeah.
Yeah.
Highly variable based on complexity. Sources suggest, simple agents might be in the, say, $10,000 to $25,000 range.
Okay, manageable for some pilots.
But advanced enterprise-level systems, the ones doing complex learning, reasoning, collaboration, they can jump fast. $40,000 up to over $500,000 easily.
Wow.
Specifically for agents built on large language models, LLM-powered task agents, the estimates hover around $50,000 to $100,000.
And service firms building their own.
If they're creating proprietary AI offerings, R&D could climb over 5% of their revenue. So, yeah, significant upfront investment, a major fixed cost.
Which needs that volume to amortize.
Got it.
What's next?
Next up, data acquisition, preparation, and management. Foundational, and the sources really emphasize the cost here.
Data. Always the tricky part.
It really is. Getting public data sets might be relatively cheap, maybe $2,000 to $5,000.
Yeah.
But private or specialized data, $10,000 to $30,000, maybe more.
And then you have to make it usable.
Exactly. Just labeling that data can add another $5,000 to $15,000. Need real-time data processing, tack on maybe $20,000 to $50,000, and the sheer effort of data preparation. That's often a huge hidden cost.
And it doesn't stop once you have it.
No way. As you scale, managing all that data storage costs, processing infrastructure, ensuring quality, governance, those costs escalate significantly too.
Okay, R&D, data. Then there's the hardware, the compute power.
Yep. Computational and infrastructure demands, a major cost driver. Agentic AI needs serious processing power, CPUs, GPUs, maybe specialized NPUs.
Whether it's cloud or on-premise.
Right. Either way, it's a substantial expense. Ongoing cloud costs might start around $20,000 a year, could be much more. Hybrid setups, maybe $40,000 to $60,000. Fully on-prem, $50,000 to $70,000 plus.
Cloud offers flexibility though, right? Elasticity.
It does, which can help manage costs by scaling with demand. But, and this is a big but inefficient models or poorly managed workloads, can still lead to rapidly escalating cloud bills. It's not automatic savings.
Makes sense. And then you need people, skilled people.
The cost of talent acquisition and retention. Specialized skills are definitely in high demand. Data scientists, machine learning engineers, AI ethics experts, orchestration specialists.
Hard to find, expensive to keep.
Exactly. This scarcity drives up labor costs. And it's kind of an interesting paradox. AI might automate lots of other jobs, but the core team needed to build and oversee the AI itself. Very expensive, and can easily become a bottleneck for scaling.
And it's not just a one-time build cost. There are ongoing expenses.
Absolutely. Ongoing operational and maintenance costs. The sources estimate annual operations can run 10% to maybe 18% of the initial build cost.
So a system costing, say, $150 to build.
Might cost another $15,000 to $27,000 annually just to keep running smoothly.
What does that cover?
Things like monitoring performance, retraining or fine-tuning the models as data changes or performance drifts, applying security patches, optimizing efficiency. It's continuous work.
You also mentioned hidden costs. What sneaks up on people?
Ah, yes. These are the ones that often bite you. Integrating with legacy systems, that comes up a lot.
Always harder than it looks.
Always. Setting up proper AI DevOps processes, establishing ongoing compliance procedures, unexpected cloud service fees. These can add, according to some estimates, 20% to 40% on top of initial projections.
Wow.
Yeah. And things like data prep taking longer than expected, the cost of implementing robust security, unexpected compute usage spikes, training users, often underestimated.
So pulling this whole cost picture together, what's the main takeaway regarding economies of scale?
The critical insight, I think, is that there's a definite scale threshold. Because those upfront fixed costs are so high R&D, data setup, initial infrastructure small deployments can look really expensive per task, per outcome.
You haven't spread the cost enough yet.
Exactly. The real economies of scale, that decrease in cost per unit, only truly kick in once you reach a volume large enough to effectively spread those initial and ongoing fixed costs over many, many operations.
Which explains the appeal of AIs as a service.
Partly, yes. Especially for smaller players who might balk at the huge upfront investment. Renting the capability can make more sense. It also highlights how interconnected these costs are. Skimp on data prep early. You'll likely pay for it later in expensive retraining or poor performance.
So you need a holistic view.
A systems thinking approach to cost management, absolutely.
And for service businesses, the sources mentioned a fundamental shift.
Yeah, that's interesting. For service firms, the value proposition potentially shifts away from purely human billable hours towards the AI models themselves and the data IP they contain. The R&D isn't just an expense, it's building a core scalable asset.
Okay, so we got the price tag. Significant investment needed. Volume is key. Now, the exciting part. What are the specific mechanisms within agentic AI that actually drive those economies of scale? What are its superpowers for efficiency?
Right, this is where the unique potential really shows up. One of the most powerful drivers, according to the sources, is replicability and marginal costs.
Ah, the software copying analogy again.
Exactly, but applied to a proactive worker. Once you've gone through the effort and cost of building and training an agent for a specific task,
Yeah.
deploying more copies, essentially scaling up your operational capacity, that's a near zero marginal cost activity.
So you can add digital workers almost instantly.
Pretty much. For a tiny fraction of the cost of hiring, training, onboarding, and managing additional human employees. The sources frame this as a fundamental shift towards software-centric scaling. Elastic, digital workforces that can flex rapidly with demand, it really changes capacity planning.
And this helps with those high upfront costs we discussed.
Directly. That's the amortization of fixed costs. Those big initial investments, R&D, platform development, agent engineering get spread over a much larger number of tasks or users as the system scales.
Lowering the cost per task.
Precisely, which is a classic source of economies of scale. And an interesting point from the sources, using smaller, perhaps more reasoning-focused models, rather than only giant generative ones, can sometimes lower initial training costs, making amortization viable even for tasks that aren't run constantly.
Makes sense. Beyond just spreading costs, the agents themselves are designed to boost efficiency and productivity, right?
That's their whole point, really. They automate complex or repetitive tasks, freeing up humans for higher value work strategy, creativity, complex judgment, empathy. This leads to faster processes, smoother workflows, basically getting more done with the same or fewer resources.
Any specific examples of gains?
Yeah, the sources had some compelling data. One study found agentic AI led to a 34.2% reduction in task completion time and a 13.6% improvement in resource utilization compared to traditional methods.
That's significant. And you mentioned a really dramatic one earlier.
Oh, the AES example, yeah, that one was striking. They reported a 99% reduction in the cost of safety audits
99%.
and cut the time it took from 14 days down to just 1 hour using agentic AI. That kind of leap?
Yeah.
That's a direct embodiment of achieving scale economies.
Yeah.
Massive increase in output relative to input.
And many of these systems, they learn. They get better over time.
That's data network effects and continuous learning. It's a really powerful aspect. Many agentic AI systems are designed to improve their performance as they process more data and gain more experience through interaction.
Like Netflix recommendations getting better the more you watch.
Exactly like that. It creates this virtuous cycle. More usage leads to more data, which fuels learning and improves performance, which then attracts more usage or allows handling more complex tasks, further driving scale and efficiency.
A compounding effect.
The sources even call it a potential compounding economy of scale, where efficiency gains might accelerate nonlinearly. That can become a really powerful, sustainable, competitive advantage.
What about those architectural points, modularity, interoperability? How do they help scale?
They enable shared platforms, reusable components, and standardization. Modularity means you can build, say, a specific agent component for data validation, and then reuse that same component across different agent workflows in finance, marketing, operations.
Avoids reinventing the wheel.
Totally. Prevents duplicated effort, speeds up deploying new capabilities. Standardization, like the idea of a web of agents mentioned in some sources, helps different agents and systems work together more effectively, creating broader efficiencies across the organization.
And building on existing work, like using pre-trained models.
Yes, leveraging pre-trained models or open source frameworks significantly reduces your initial startup cost and development time. You can scale customized solutions much faster by building on those existing foundations. Tech companies like NVIDIA are actively developing tools to help enterprises build these kinds of interconnected, reusable agent ecosystems. It's classic software scaling logic applied here.
And underpinning a lot of this, especially for larger deployments, is the cloud.
Cloud computing is definitely identified as a key enabler for most organizations. It provides that crucial elasticity.
The ability to scale resources up and down.
Exactly. Dynamically scaling compute and storage based on demand. This means you avoid the huge upfront cost of buying and maintaining enough hardware for your absolute peak load, which optimizes infrastructure spend.
Plus, the cloud providers have their own scale advantages.
Right. They benefit from massive economies of scale, bulk purchasing, hyper-efficient data center operations, and they pass some of those savings on. It significantly lowers the barrier to entry for accessing the kind of powerful compute needed for serious AI.
Makes advanced AI more accessible.
It absolutely does. But the sources also caution here. While the cloud enables scale, it does create dependency, potential vendor lock-in.
And costs can still spiral.
Oh, yeah. Despite elasticity, cloud costs need very active management and continuous optimization. If you're not careful, bills can escalate rapidly. So managing cloud resources effectively is key to making that scale sustainable.
Okay, so the potential for scale, driven by these mechanisms, seems very real. But as you said earlier, it's not guaranteed. What are the big roadblocks, the challenges the sources highlight that can prevent or even reverse these economies of scale?
Yeah, the path is definitely littered with potential pitfalls. One really significant challenge is the sheer complexity and coordination overhead.
Meaning, as you add more agents, it just gets harder to manage everything.
Potentially exponentially harder, yes. As you scale up multi-agent systems, managing all their interactions, ensuring they work together coherently towards a shared goal, preventing unintended conflicts or chaotic behavior, it becomes incredibly complex.
Orchestrating them all.
Exactly. Orchestrating autonomous agents across different systems, different data sources, it's intricate work. And the black box nature of some advanced AI models doesn't help. Debugging problems at scale can be incredibly difficult and costly.
So the management cost could outstrip the benefits.
That's the risk of diseconomies of scale setting in, if the overhead grows faster than the efficiency gains. Some sources even suggest unlocking complex AI scale might need fundamental breakthroughs in orchestration technology itself.
Okay, complexity. What else? Data governance.
Data governance at scale is huge, consistently cited as a top concern. I think one source said for 53% of organizations.
Why is it harder at scale?
Well, with vastly increased data volumes and agents acting autonomously, ensuring compliance with complex privacy regulations like GDPR or CCPA becomes much harder. Security risks also escalate data breaches, potential malicious use of agents. Agentic systems have unique vulnerabilities.
The cost of locking all that down.
The cost and sheer effort of implementing and maintaining robust governance, security, and compliance frameworks at scale can substantially limit the net economies you actually achieve. It's a major overhead.
And then there's a classic IT problem, integration with legacy systems.
Oh, yeah. A major hurdle for about 40% of enterprises, according to one source. Older systems often lack modern APIs.
The connections for software to talk.
Right. Or they use outdated data formats. This makes integrating them with modern agentic AI platforms really costly, slow, and error-prone. It can derail projects.
Rigid architectures, too.
Exactly. Makes it hard to update things, like swapping out one LLM for a newer, better one, unless you've cleverly built in abstraction layers like AI gateways. Without good integration and orchestration, you can end up with infrastructure sprawl, disconnected systems, wasted resources. It really erodes the potential scale benefits.
So legacy tech debt really holds back AI scaling.
Significantly. Organizations without a mature data and IT architecture will find scaling AI very, very difficult.
We touched on talent earlier, but that remains a scaling challenge too. Talent bottlenecks and skill gaps.
Absolutely. Still a significant barrier, a concern for about a third of organizations in one survey.
Yeah.
The shortage of specialized AI pros either drives labor costs way up or it simply slows down your ability to deploy and scale because you just can't find the people.
And the skills needed are evolving too.
Yeah, skills in AI ethics, sophisticated prompt engineering, large-scale orchestration, they're scarce. And the human expertise needed to effectively manage, govern, and troubleshoot these complex autonomous systems might not scale at the same pace as the tech itself.
Which brings us to the ethics and oversight piece.
Yes, ethical considerations, potential bias, and the need for human oversight. Crucial challenges highlighted in the sources. Ensuring agents make decisions that are ethical, fair, and unbiased, especially as they operate more autonomously at scale, that's paramount.
Data bias is a big risk.
A significant one flagged repeatedly. And then there's the need for human oversight. For critical decisions, for handling edge cases or exceptions, maybe as an appeal mechanism, but that oversight function might not scale linearly.
You can't have one person watching thousands of agents effectively.
Right. Designing effective, scalable human-AI collaboration is complex. Accountability for agent actions becomes a bigger issue at scale, and the costs of implementing robust ethical AI frameworks, mitigating bias that adds overhead, cutting into the net economies.
It's almost a paradox. You need autonomy for scale, but oversight limits autonomy.
Exactly. Some sources call it a scalability paradox. We need to figure out truly scalable oversight mechanisms to resolve that tension.
And let's not forget the simple barrier of high initial implementation costs.
Still a major factor, cited by 39% as a barrier. That substantial upfront investment can simply deter organizations from even starting. Or they might spend their budget before reaching that critical mass, that scale threshold, where the benefits really start to pay off.
Run out of runway before takeoff.
Essentially, yeah.
And lastly, that risk you mentioned earlier. Infrastructure sprawl and inefficient orchestration.
Right. If you don't have good centralized management, smart systems allocating resources, and cost awareness baked in, you can easily end up with wasted compute, bloated cloud bills, even if you're using theoretically elastic infrastructure. Efficiency leaks everywhere.
Okay, so achieving scale with agentic AI is clearly not automatic. Lots of hurdles. So what did the sources suggest are the strategic pathways? How do companies actually navigate this and realize those economies of scale?
It definitely requires a deliberate strategic approach, not just hoping for the best. One key strategy emphasized is phased implementation.
Don't try to boil the ocean. Start small.
Exactly. Start with really clear objectives. Identify high-impact use cases first. Maybe prioritize tasks that are highly repetitive, very data-intensive, or where human scaling is already a known bottleneck.
Okay.
And here's a surprising tip from the sources. Don't just look at automating tasks you're already doing. Also consider automating valuable tasks you aren't doing today because they were too costly or complex manually.
Expanding capabilities, not just cutting costs.
Right. It adds a different dimension to the value proposition. And the general advice is, start with pilots, minimum viable products, MVPs. Get faster ROI, build confidence, get buy-in, learn lessons, then scale incrementally.
And thinking about scale from the start in the design.
Crucial. Designing for scalability is non-negotiable according to the sources. Those architectural choices you make early on, they have huge long-term consequences.
Like modularity.
Yes, use modular design. Prioritize interoperability using standardized interfaces like APIs. Choose your tools, your frameworks, your underlying AI models with scalability and compatibility in mind.
And those abstraction layers you mentioned. AI gateways.
Consider them seriously. They can decouple your agents from specific LLMs or back-end services, giving you flexibility later to swap things out, manage costs, avoid vendor lock-in. The point is, build for scale from day one to avoid painful, costly re-architecture later.
Okay, phased approach, designed for scale. What about the data foundations?
Also non-negotiable. Investing in robust data infrastructure and governance. This came up again and again.
Got to get the data house in order first.
Absolutely. Modernize your data architecture if needed. Unify platforms where it makes sense. Implement consistent controls for data quality, privacy, security, compliance, especially crucial with regulations like GDPR, CCPA.
And managing the data flow.
Efficient data management, cleaning, prepping, storing, providing access is essential for agents to work well at scale. And you must establish clear accountability for agent actions before you let them loose on critical processes.
Auditing, transparency.
Implement auditing, transparency where feasible. Proactive bias mitigation strategies. The sources stress this investment in data and governance isn't just a cost center, it's a strategic enabler of trustworthy, scalable AI. Without it, scaling is just too risky and inefficient. It requires developing new skills too, like AI economics management to track costs.
Makes sense. It's also a huge change for the people involved, right?
Definitely. Fostering human-AI collaboration and managing change is critical. Agentic AI fundamentally changes work. Ideally, it frees people from drudgery for more strategic, creative, human-centric tasks.
But people need help adjusting.
For sure. Invest in training employees. How to collaborate effectively with agents, how to interpret their outputs, how to handle exceptions, when to trust them, when to intervene.
Change management is key.
Vital. Having internal AI champions helps. Clear, consistent communication is crucial for adoption, overcoming fear or resistance. The sources warn that the human factor can absolutely bottleneck technical scaling if you don't address the organizational change thoughtfully. Focus on empowering employees.
Okay. And finally, these systems aren't static once deployed.
Not even close. Continuous monitoring, evaluation, and optimization is an essential ongoing process.
What does that involve?
embedding cost awareness right from design through to operations, using tools like evaluation engines or MLOps platforms.
Machine learning operations.
Right. To continuously test different configurations, balance the trade-offs between cost, accuracy, speed, implement smart orchestration systems that route workloads efficiently, auto-scale resources intelligently to avoid waste and control costs.
And keep tracking performance.
Constantly. Monitor agent performance against your actual business KPIs. Refine the system based on new data, user feedback, performance drift. It's an active, ongoing cycle to make sure those economies of scale are actually achieved and, importantly, maintained over time.
Wow. Okay. So looking back at everything we've unpacked in this deep dive, the potential for agentic AI to deliver significant economies of scale seems, well, pretty strong on paper.
It does. That potential is really driven by core capabilities. Replicating agents cheaply, spreading those high upfront costs, the potential for dramatic efficiency gains, that continuous learning and data network effect, and leveraging shared platforms and the cloud.
And it's big bits, but actually realizing that potential isn't a given.
Not at all. You absolutely have to proactively tackle those challenges we discussed. The complexity of coordination, ensuring rock-solid data governance and security at scale, wrestling with legacy IT integration, navigating talent shortages, managing the crucial ethical dimensions and oversight needs, and of course, overcoming those significant initial costs.
So it really boils down to a strategic, disciplined approach.
Exactly. Starting phased, designing for scale from the get-go, making those non-negotiable investments in data and governance, actively fostering the human-AI collaboration piece, managing the change, and committing completely to continuous monitoring and optimization.
If companies can do all that, the payoff could be huge. Redefining operational efficiency, enabling new business models.
It really represents a potential paradigm shift, moving away from growth being automatically tied to adding more people towards a future of more agile, cost-effective, intelligent automation.
So here's a final thought to leave you with, kind of building on what we've heard from the sources.
Okay.
Could achieving the fullest expression of economies of scale with agentic AI actually depend less on individual companies building everything themselves in silos,
Yeah.
and more on industry-wide standards emerging? Shared agent capabilities, maybe? Creating ecosystem-level efficiencies, sort of like how the internet infrastructure did?
That's a fascinating question. OR, does the sheer massive cost of training truly cutting-edge models and acquiring the necessary unique data sets mean that only a handful of very large players, AI superpowers, if you will, can really capture the full benefits of scale?
Potentially leading to more market concentration.
It's possible. It raises big questions about the future shape of competition, where value gets created, and who captures it in this rapidly evolving AI-driven economy. Something to definitely keep watching.
Definitely. Well, thanks for joining us for this deep dive.